All right, let's talk about slope some more. But what I'm going to do is we're going to graph on an XY axis. All right, so I've got a nice little graph paper here. Oh goodness, let's try that again. Let's start way up here like this. And go down to about right there. That's a good one. And does that look like in the middle right there? Close enough. All right, there we go. That looks nice. What I'm going to do is put some points in here. Let's go a different color. Let's go red. I'm just going to pick some two random points. Here's one right here, and let's say that one right there. Okay? No, let's not pick that one. Let's go up a little higher. Let's pick this one way up here. All right, we good? Nothing special about those points. They're just points that I saw that I picked. Let's extend this one out, and let's extend this one out just a little bit more. Okay? There's a line. What we want to do is we want to find the slope of this line. Let me show you something real quick here. There's a couple ways you could do it. You could just go rise over run, couldn't you? Okay, but let's put the point in here. What would this point be? Let's actually write in the ordered pair for that point. Let's count. 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5, 6. So 5, 6. Agreed? Let's find this point right here. What's that? 1, 2, 3, 4. Negative 4. What? Negative 2. Negative 4, negative 2. Now watch. You could sit there and just count the rise and count the run. I want to show you something else, okay? When you think of rise over run, rise goes along the y direction, up and down. Run goes along what? The x direction, okay, across. You follow me? So what is the y point of this point right here? It's 6, isn't it? See? It's 6, agreed? Come down to here. What's the y point of that point right there? That's negative 2, isn't it? So look, I'm at 6 and I'm at negative 2. How do I find the distance? Right? We did this way earlier in the year. How do I find the distance between 6 and negative 2? It's vertical. I don't have to use distance formula. All right? It's way easier than that. How do I find the distance from this point to this point? Just do what? Say it. Subtract. Right. Just subtract them. Would you agree? So I take this point, this y point, and I subtract this other what? Y point from it. You see it? So I take the 6 and the negative 2 and I subtract them. So 6 minus what? Not just 2, negative 2. That's the rise. Now I got to find the run, don't I? So I got to go from where to where? From here to here. Okay, what's this point on the x-axis? It's 5, isn't it? Okay, and what is this point on the x-axis? It's negative 4. So what do? I subtract. Now watch. I went from this top point to this one. So I went 6 minus negative 2. I got to subtract the x's in the same exact order. So what would I subtract? 5 minus negative 4. You see that? And that's how I find the distance. Now, I could have sat there and just counted, couldn't I? And that would be okay. If you have a graph, sure, you could just count 1, 2, 3, 4, 5, 6, 7, 8, right? You could count it. But what if you didn't have the graph? What if you just had the points? Then you'd have to graph it, you'd have to count and all that kind of stuff. But if you just have the points, what can you do with the points? Just do what to them? Just subtract them. That's right. Just subtract them from each other. Okay, I think that's a lot easier, don't you? And so I subtract the y's, I put that on top, and what do I get? 6 minus negative 2 is 8. Let's subtract the x's. So I subtract 5 minus negative 4, which is 9. So what's the slope of this thing? It's 8 over 9. Okay, and that's the slope. Now for some reason, they give the slope a letter, a certain letter. You remember what that letter is? You'd think it would be S for slope, wouldn't you? But it's not, though. Anybody remember what it is? It's not R. M. Did you remember that? Yeah. M is the what slope stands for. Okay. There's a debate on the reasoning behind that. I looked it up a couple years ago, and I think they're not really sure 100% where the M came from because it goes way, 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 way back. I mean, like hundreds, thousands of years actually. Okay. with the M. They think it comes from like the Latin word from something that kind of means mountain. It doesn't really stand for M for mountain, but it comes from a Latin that talks about hills and stuff like that, I think. That's what the consensus is. That's why they use the letter M. Does that make any sense? It kind of makes sense. Yeah, because mountains are hills and they're steep and they got slopes and all that kind of stuff. So that's what they use for that. All right? That's why they use the letter M. And that's how you would find the slope. Really, really simple. Now, you could also just count, couldn't you? From here to here. You could count. Let's do it. 1, 2, 3, 4, 5, 6, 7, 8. But we went down, didn't we? So if we went down, what did we say earlier? This would be -8. And you're like, wait a minute, this wasn't -8. But let's take a look at this. Then I have to do what? Go this way. It's hard to write on this pad going left like that. Go that way. How many did we go? 1, 2, 3, 4, 5, 6, 7, 8. What? 9. But we went to the left, so what's that? It's negative. But what is -8 over -9? It's positive, right? Negative over negative is positive. 8 over 9. So you get 8/9 either way, don't you? All right? If you wanted to, you could count up. Count up, it would be what? +8, and count to the right would be +9. So a bunch of different ways you can find the slope of this. To me, I think the easiest way is just find the points, subtract the y's, subtract the x's. Make sure the y's go on top. How can you remember the y's go on top? Because it's rise. It's rise over run. By the way, here's how they write it officially. They put slope equals. What did I do right here? I subtracted the y's, didn't I? So I'll take one y point, call it y1, and subtract the other y from it. y1 minus y2. Is this looking kind of familiar? Remember we did this with midpoint and distance formula? But this is slope this time. And then over the run. What do you think? How do you think I would write the run? If this was y1 minus y2, this would be x1 minus x2. Very good. Make sense? Right there in that box, that's the formula for slope. Memorize it. You have to know it. All right? So memorize what the slope of a line is. If you can remember rise over run, just think, okay, subtract the y's, put it on top, subtract the x's, put it on the bottom. If you can remember that, it's a piece of cake. Really, slope is pretty easy. Now, we're going to do a lot more with slope with something else, an equation of a line, but right now, just slope itself is actually pretty simple to do. And it's important. We're going to use it in a lot of different math stuff that we do later on. All right, let's do an example, another example, and I'll pause this, get rid of this stuff. All right, here's an example. You're going to have two styles of problems that I'm going to give you tonight. One is what we just finished doing. They actually give you a graph, okay, on an XY axis. They give you a graph, and you got to find the slope of that line. It's what we just finished doing. Then the second part of this is going to be, they're just going to give you the 2 points. They're not going to give you a graph, and you don't even have to graph it, which is nice. All you got to do is find the slope between those 2 points. So let's make something up. I don't know, -3, what, -2? Give me a nice, fairly easy point. 1, 7. Okay, we'll work with that. And what it's going to say is this. It's going to say find the slope of the line between these 2 points. You hear me? Find the slope of the line between these 2 points. So I need a formula. Do I have a formula for slope? Sure, I just talked about it. Yeah. That's right. Subtract the y's, put it on top, and subtract the x's and put them on the bottom. It's rise over run, isn't it? It's not that hard to remember. It's not like you have to sit there. Break your head up, please. It's not like you have to sit there and remember, okay, y1 minus y2 over x1 minus x2. Don't memorize that necessarily. Memorize rise over run. Oh, how do I find the rise? Oh, I just subtract the y's from each other. How do I find the run? Oh, just subtract the x's from each other. Right? Can you remember that? Yeah, if you can remember that, it's not hard to remember that formula. Now, it's really easy to work to get the answer. You just take the y's and you subtract them. Which ones are the y's here? The -2 and the 7. Now, it doesn't matter which order you subtract them as long as you subtract the x's in the same order. You okay with that? So if I go the first one minus the second one, then I got to take the first x and subtract the second x from it. You got it? All right, so what do you want to do? -2 minus 7? All right, I subtracted the y's, put them on top. Now, in the same order, I got to subtract the x's. So it's -3 minus 1. All right, and let's work this out. -2 minus 7 is -9, and this is -4. Don't leave it like that, though. What's negative over negative? It's positive, right at 9 over 4. Now watch. Did I change that to a mixed number? No, not at all. Did I change it to a decimal? No, not at all. Slopes should always just be in fraction form. All right, one numerator, one denominator. No mixed numbers. Everybody got that? Do not ever write a slope as a decimal or a mixed number. Keep it an improper fraction if it is improper. If it's just a regular simple fraction, then just keep it that way as well. Always reduce it though. What if it came out to, this is not this problem, but what if it came out to like 6/4? Would you leave your slope like that? That's right. You'd always reduce it to 3/2. You got it? Always reduce it, but if it's improper, keep it improper. We good? Okay. And that's the kind of stuff that they're going to ask you to do. Now, I know I've been giving you worksheets. I just completely forgot to print it out this morning. I had a planning period already, and I just forgot. I got busy doing some other things. So I'm going to have you do problems from the book. So it's going to be page 191. And we are going to do 12 to 25. Okay, so everything that we've done in class today is covered in this problems right there. It's right in front of you. We are. So it's page 191, numbers 12 to 25. All right, so you're going to do all those. All you're doing is finding the slope. That's it. The first section, they give you a graph and you find the slope. The second section is like this, where they give you 2 points and you find the slope. All right, you should definitely know how to find the slope after you do this. Lesson. It's not that hard. Make sense? Yeah, it's pretty easy stuff, I think. And we are out at. Look, you got like 7-8 minutes left. Okay, so let's start on it now. Open up your books, page 191, and let's work on them. Okay. What do you do? Oh, you have to leave early. Okay, that's fine.